Hello students, this is about the chapter Some Basic Concepts of Chemistry. Chapter 1, Class 11th. First we'll see classification of matter on the basis of chemical composition. Pure substance. Pure substance is a substance in which all the constituent particles are of the same chemical nature. This can be further classified into elements and compounds. An element consists of only one type of particles, atoms, or molecules. For example, sodium, copper, hydrogen, or oxygen. A compound consists of two or more atoms of different elements combined in a definite ratio by mass. For example, ammonia or water. Now, mixture. A mixture consists of two or more substances mixed in any ratio. A mixture may be either heterogeneous, that consists of distinct phases, or homogeneous, that consists of a single phase. In a homogeneous mixture, the composition is uniform throughout. For example, salt in water. However, in a heterogeneous mixture, the composition is not uniform throughout. For example, sand in water. Now, let us study significant figures. Significant figures are meaningful digits which are known with certainty. One example is given here that in 52.4 ml, 52 is certain and 4 is uncertain, and the uncertainty would be plus or minus 1 in the last digit. Now have a look over what are the rules for determination of the number of significant figures. The first rule is all non-zero digits are significant. Second, zeros preceding to first non-zero digit are non-significant. Zeros between two non-zero digits are significant. Zeros at the end or right of a number are significant on the right side of the decimal point. And the last rule is the terminal zeros are not significant if there is no decimal point. Now, let us have a study about laws of chemical combination. First law, it's law of conservation of mass. It is stated by Antoine Lavoisier. It states that matter can neither be created nor destroyed in a chemical reaction. Or we can say the total mass of reactants is always equal to total mass of products formed. So here we can also say that total mass of reactant and total mass of product if reactants are totally consumed. It's always equal, as you can see here. Next law is law of definite proportions. This law is stated by Joseph Proust. It states that all pure samples of the same chemical compounds contain the same elements combined in the same proportion by mass. Example, CO2 can be obtained from different sources, but the ratio of carbon and oxygen remains same, that is 3:8 by mass, irrespective of the source. Next law is law of multiple proportions. This law is given by Dalton. It states that when two elements can combine to form more than one compound, the different masses of one element that combine with a fixed mass of the other element bear a simple ratio to one another. For example, carbon forms two oxides with oxygen. Carbon monoxide, CO, and carbon dioxide, CO2. The ratio of masses of oxygen in carbon monoxide and carbon dioxide for fixed mass of carbon, that is 12 gram 1:2, which is a simple ratio. The next law you can see here is Gay-Lussac's law of combining volume. And the law states that whenever gases react together, the volumes of the reacting gases as well as the products, if they are gases, bear a simple whole number ratio, provided all the volumes are measured under similar conditions of temperature and pressure. Or you can just write, children, at constant temperature and pressure. Have a look over the example. H2 plus Cl2 gives twice of HCl. All the components are gaseous and it bears a simple whole number ratio, that is 1:1:2. The next law you can see here is Avogadro's law. According to Avogadro, at constant temperature and pressure, equal volume of different gases contains equal number of particles or molecules in it. You can see the example here in the pics that three different gases are there: oxygen, hydrogen and water vapor. But the number of particles in their equal volume will always remain same. There will be no difference. Now the next topic is atomic mass. The atomic mass of an element can be defined as the mass of one atom of the element relative to the one atom of carbon-12 isotope. It is measured in atomic mass unit, AMU or U. One atomic mass unit is defined as 1/12 the mass of one atom of C12 carbon. Mathematically, we can write 1 AMU atomic mass unit is equals to 1.66 multiply 10 to the power minus 24 gram. Now, gram atomic mass. Atomic mass of an element in grams is called gram atomic mass for gram atom of an element. Gram atomic mass of any element is the mass of 6.022 multiply 10 to the power 23 atoms of the element. It can be calculated by the formula mass of one atom in grams is equals to gram atomic mass divided by Avogadro number. Now molecular mass. Molecular mass of a compound can be defined as the mass of one molecule of the compound relative to the carbon atom taken as exactly 12. Gram molecular mass of the mass of a compound in grams. It is the mass of 6.022 10 to the power 23 molecules of the compound. We can calculate mass of one molecule in gram using the formula gram molecular mass divided by Avogadro number. Now molar volume. Molar volume of gas is the volume occupied by 1 mole of it at STP or NTP. STP is standard temperature and pressure. 22.4 liters at NTP is the volume occupied by 1 mole of any gas at 1 atm or atmospheric pressure. 22.7 liter at STP is the volume occupied 1 mole of any gas at 1 bar pressure. You know, children, where atm and bar are the units of pressure. So I hope you understood all these things. Thank you.